Now we need to show that the following 3 points A, B and C are collinear. Okay, let us begin. So here we have the points A, B and C. And we will be considering another point O, which is going to be the origin of some coordinate system. With respect to this origin, we can define the position vector of point A. All we have to do is join point O and A with the help of a directed line segment going from O to A. Since the coordinate of the point A is given to us, so that's -3, -2, -5, so we can define the position vector of point A. Now let us suppose that OA is the position vector of point A. Now how do we find out the position vector of a given point if we know the coordinates of its endpoints? The coordinate of the origin, that's going to be 0, 0, 0. All we have to do is take the difference of the coordinates. That means for the x coordinate, we take -3 minus 0, multiply it with I cap. For the y coordinate, we take the difference of the y coordinates, we have -2 minus 0 times j cap. And for the z coordinate, we take the difference of the z coordinate, -5 minus 0, multiply with k cap. The OA vector comes out to be -3 I cap minus 2 j cap minus 5 k cap. So this is the position vector of point A. Similarly, we can find out the position vector of the other 2 points. The OB vector comes out to be I cap plus 2 j cap plus 3 k cap. And the position vector of point C, the OC vector, comes out to be 3 I cap plus 4 j cap plus 7 k cap. Fine. Now what we'll do? We will find out the vector AB. So that means we need the vector OB for this. So vector AB vector, this is defined as OB vector minus OA vector. That's the definition. So let's substitute the value of OB. The OB is I cap plus 2 j cap plus 3 k cap. And from here we're subtracting OA vector. So we're going to get +3 I cap plus +2 j cap plus 5 k cap. Simplifying gives us 4 I cap plus 4 j cap plus 8 k cap. So this is our vector AB. Fine, we're going to label this as number 1. Next, what we'll do, we'll try to find out the vector BC. To find out the vector BC, we need OC vector as well. So now we have a BC vector. The BC vector, that's going to be equals to OC vector minus OB vector. Now what is OC vector? OC vector, that's given by, here we have 3 I cap plus 4 j cap plus 7 k cap. And from here, we're going to subtract the vector OB. OB vector, that's I cap plus 2 j cap plus 3 k cap. Simplifying gives us I cap plus 2 j cap plus 4 k cap. That's 2 I cap actually. Okay, so this is the vector BC. We're going to label this as number 2. Now we can see there's a close relationship between AB vector and BC vector. So here we see that AB vector can be also expressed as, if we take 2 as the common factor, so we have 2 times 2 I cap plus 2 j cap plus 4 k cap. Now here we can replace 2 I cap, 2 j cap and 4 k cap with BC vector, which means that we have 2 times the vector BC. Now this is our vector AB. So AB vector equals 2 times BC vector, which is of the form AB vector equals to lambda times BC vector, where we have considered lambda to be equals to 2. Now, whenever this particular criterion is met, this simply tells us that the points, the 3 points A, B and C are collinear. So we have successfully verified that the 3 points A, B and C, whose coordinates are given to us, are collinear.